And so today we want to consider structure of an atom. What then is an atom? An atom is the smallest particle of an element that can exist alone and still retain the properties of that element. Meaning that if it's possible to break down an element and just pick out an atom of that element, it will still possess the properties of that element. That you can identify that, oh, this atom is the atom of hydrogen, and this atom is the atom of oxygen, and all that. You see, it's important to note that atoms are made up of elementary particles, and these particles are protons, electron, and neutron. Let's consider the very first one now, the proton. The proton is the positive particle present in an atom. Like I said, atom has three particles inside: protons, electrons, and neutrons. But you see this proton, that is the positive particle in an atom. So amidst these three particles, one of them is positive, and that happens to be the proton. The proton is responsible for most physical properties of an atom. And it's important you note that the number of proton an atom have, that is the same as its atomic number. For example, now if you can find 2 protons in an atom, that the atomic number of that atom is 2. If you can find 10 protons in an atom, then the atomic number of that atom is 10. Now let's look at the very next one now, electron. Well, this is the negative particle of an atom. So like I said, amidst these 3 atoms now, one is positive, which is the proton. Then one is negative also, and that happens to be the electron. You see, the electron is located not in the nucleus, but outside the nucleus of an atom. You see, an atom has a center. In this a very tiny center. In this center, inside the center, that's where the proton lives. I didn't mention that. But electrons live outside this center, anywhere outside this center. And the place where electrons stay are called orbital. I often hear people say that electrons are located in the shell. No, that's not correct. Electrons are located in the orbitals. What is orbital actually? Orbitals are places where there are high probability of finding an electron. And when we say high, there's probability or possibility of finding an electron there, it is simply because electrons behave like waves. And you know, waves is a disturbance actually within a region of space. And so you can't say a wave is particularly in a place but affects a region of space. That is a wave. That's the same thing when we say orbitals, a region of space where an electron is contained or where you can find an electron. Now, it's important to note now that this electron exists in levels. It's just like humans live in ohm, but you know, they are fine ohm and they are bad ohms, or you can say they are poor ohms and rich ohms. The same way too, you classify these orbitals. Some orbitals has low level of energy, some orbitals have high levels of energy. Now, this is what I mean now. For instance now, the lowest level now is the K shell. Orbitals that are found there has lower level. We have the next one, which is like L. This is the K, for instance, L. Then we have another one, which is the M. Orbitals that are here have more energy than orbitals that are here. On and on, N, and continuously. Most often, we represent this with something that looks like rings. And that's why people say electron stays in shell, but that's not correct. If this is the nucleus, for instance, then we say this is the K shell. Electrons. This electron doesn't mean they live in shell, but that they belong to this level of energy. The same way too, This is the L, for instance, and then electrons are in this level. Now, this place where electrons are called orbitals actually, but the levels of these electrons is the L energy level. Just like you say that you cannot say humans live in rich. No, humans live in houses or homes, but those homes cannot be classified as rich homes or poor homes. But you cannot say that humans now live in rich, or the same way too, you cannot say electrons lives in shell, but they live or they stay in orbitals, and those orbitals has level. So that's that about that. So we can call this the K, you can call this the L, there's another one again, M, on and on, different levels of energy. Now, it's important that the electron or electronic configuration tells the chemical properties of an atom. Is what helps us to know or predict the chemical properties, or is responsible for the chemical properties of an atom. And lastly, it's important to note that a neutral atom has equal number of protons and electrons. How do you know a neutral atom, for instance? Neutral atoms are written in this way. H, for instance, Cl, for instance. These are all neutral atoms. If an atom is not neutral, then you say it's a charged atom or is an ion. Either you say charged atom or ions, and they're like this, for instance. For instance. So they have plus or minus. They could look like this. So these are charged atoms or ions. Why these are neutral atoms? If an atom is neutral, take note that the number of protons you find in it is the number of electrons you find in it. For instance, this hydrogen contains 1 proton. Hence, it also has 1 electron. This chlorine contains 17 protons and 17 electrons. This argon contains 18 protons and 18 electrons. And sodium here contains 11 protons and 11 electrons. But the electrons and protons here are not the same because these are charged. These atoms have either gained or lost electron. The positive ones have gained electron, the negative ones have lost electron. But we'll talk about this as we proceed when we get to ions. So the last atomic subparticle is the neutron. The neutron is the neutral subparticle. Like I said, we have 3 subparticles: protons, electrons, and neutrons. So let's consider the third subparticle, the neutron. The neutron is the neutral subparticle in an atom. You know, like I said, we have 3 subparticles: protons, electrons, and neutron. The proton is positive, the electron is negative, and the neutron is neutral. It is also located in the nucleus, inside the nucleus, the same place where the proton is located. And so, this is the structure of an atom now. Inside this atom is a small center. Don't mind how big this is, but very, very small compared to the size of an atom. Inside this small center, which is called the nucleus, is where the proton, positive, and the neutron exists. So this is the nucleus. Outside the nucleus is where the electron stays in a place called orbital. And so the summarized characteristics of an atom is just shown below here in this table. So that's that about that. If you look carefully here, you see that the relative mass of the proton is just 1 relative. That's compared to others, 1. It's compared to neutron, for instance, 1. And then the relative mass of the neutron is also 1 compared to the proton. And the relative mass of electron compared to proton is about 1 over 1,840. So 1 over 1,840. That's how small this is. Let me make it look reasonable. This is about 0.0005. Why this is 1? Imagine how insignificant this is to this. That's just it. And that's why electron does not contribute to the mass of an atom, because it's relatively very, very light. When we get to mass number and atomic number, we'll talk about that. For mass number, it's just the sum of proton and neutron. You don't talk about electron because electrons are very, very light. So that's that about that. Next is we see how these particles are attracted. The electron is attracted towards a positive charge, and the proton is attracted towards negative. And that's to tell that protons are positive. Why? Because they are attracted to a negative plate. Why electrons are negative, and now you can see they are attracted to a positive plate. Neutron are neutral. That's why they are not deflected. It doesn't deflect to the negative plate or to the positive plate. So that's that about this. I can give you this in an exam and clean up this and call this X, for instance. I can make this X, for instance, and make this Y, for instance, and make this Z. And then ask you, what particle is X? You should know, for the fact that this is attracted towards the positive plate, this should be the S should be electron. For the fact that Y is not deflected at all, it should be the neutral. And for the fact that Z is deflected towards the negative plate, this should be the proton. It's also important to note that the neutron was discovered by James Chadwick, and then the nucleus and the proton was discovered by Ernest Rutherford through his alpha scattering experiment. It was Ernest Rutherford that made us realize that an atom look like the solar system, where the nucleus is at the center of the atom, just like the sun is at the center of the solar system. And then electrons revolve around the nucleus, just like the planets revolve around the sun. So its atomic theory looks like that of the solar system. But we all come to all of this when we talk about the atomic theory, but I'm just giving this first-hand information. Again, that the atomic number is also discovered by Henry Moseley. So we want to look at the atomic number. The atomic number is the number of protons present in an atom or present in the nucleus of an atom. You see, it simply means that if an atom has 5 protons, the atomic number is 5. If it has 7 protons, atomic number is 7. And if it has 20 protons, atomic number is 20. So it means that the number of protons you will see in any atom is the atomic number of that element or of that atom. And then the atomic number should also tell you the number of protons. Obviously, if an element has atomic number of 20, obviously it must have had 20 protons. So the number of protons tells you the atomic number of an atom. It's represented by letter Z. So in chemistry, if you see Z, it's simply talking about atomic number. And it was discovered by Henry Moseley. Next is the mass number. The mass number is the sum of proton and neutron in an atom. For instance now, an element has 5 protons and let's say 6 neutrons. Then the atomic number should be 5 plus 6. That's 11. Just sum the proton and the neutron. You get the mass number. So the mass number is the sum of proton and neutron. Please take note of that. So it is represented by letter A. So if you see A, it simply means mass number, which is sum of proton and neutron. Now it's important to note that the nucleon number still is the same as the mass number, because you see the nucleon number simply means the sum of all entities or subparticles present in the nucleus. That is the nucleon number. So let's look at representation of an element. You see, an element can be represented as shown. Here I'm using X to indicate any element. X actually means any element. You see, the mass number is always written here as a superscript, while the atomic number is written beneath here as a subscript. So, where X is any element, and then A is the mass number, and then Z is the atomic number. And so for instance now, if I want to represent sodium, whose atomic number is 11 and mass number is 23, it should be written like this. This is sodium, then the mass number written here, 23, and the atomic number written like this. If I want to represent oxygen, for instance, whose mass number is 8 and atomic number is 16, it's going to look like this. 16 as the mass number, atomic number 8. So on and on. This is how an element can be represented. An element has 7 protons and 7 neutrons. 7 neutrons. Okay? So find 1, its atomic number, 2, its mass number, and 3, the number of electrons it has if it's a neutral atom. Now to solve this now, first and foremost, we are told that the proton is 7. That's the given. We are given that proton is 7 and that the neutron is 7 as well. And now we're looking for the atomic number. Atomic number, which is Z. Since atomic number is the number of proton, so since I have 7 proton, atomic number should be 7. And that's that for the first one. Now the second one says its mass number. We know that the mass number is sum of proton plus neutron. And so that will be 7 plus 7. And that's just 14. Now, the last one is we have to find the number of electrons it has if it's a neutral atom. Now, if an atom is neutral, the number of protons it has will be the number of electrons. So number 3 now, find the number of electrons it has if it is a neutral atom. Okay? So we know that a neutral atom has equal number of protons and electrons. And so number of electrons is same as number of protons for a neutral atom, and hence number of electrons will be 7 since the number of protons is 7. That's that for this example. So the second example here says an element has 17 protons and 18 neutrons. 1. Is the element neutral? 2. What is its atomic number? 3, what is its mass number? And then represent the elements. But let's solve this now. First and foremost, we have to tell, is the element neutral? Now, because we know that for an element to be neutral, it must have equal number of protons and electrons. Meaning that if it has 5 protons, it should have 5 electrons. Now, we're not given the number of electrons here. And since we don't know the number of electrons, we can't assume for it. So, therefore, we cannot determine if it's neutral. Had it been we are told here that it has 15 or 16 electrons, then we can say it is not neutral since it is not equal to the number of protons we can see here. Or if we are told that it has 17 electrons, then we can say it is neutral. But since we are not given any information concerning its electron, then we can say it cannot be determined. So we cannot determine if it is neutral or not. Number 2, its atomic number. Well, atomic number is 17. Since we are given in this question that proton is 17 and the neutron is 18. The next we are asked here is the mass number. And the mass number is proton plus neutron. And that will be 17 plus 18. That's simply 35. Now, I could have asked, what is the nucleon number? And that's still 35 also. So let's proceed now. Now we have to represent the element. Now, which element has atomic number to be 17? That's actually chlorine. And so, since I know it's chlorine, I'm going to write Cl, chlorine. Then write the mass number here, 35, and atomic number here, 17. We've done the fourth one, representing the elements.